Good morning. My name is Grant Kovac. I'm the Director of Product Management for Vilter. That's the industrial business unit within Copeland. I'm joined with Jonathan Burney, who's our Director of Business Development for Canada. I'm going to be talking to you about a scalable approach to high-temperature heat pumps and district heating applications. I'm going to do a little work to introduce the product that we have at our booth in Hall 6. And then Jonathan is going to give us an example of an active order that we're working on for district heating in Canada. Before I kind of unpack the product, I think it's necessary for me to also talk about the market. So over the past year plus, we've been working a lot to understand the market here in Europe. A lot of decarbonization goals specifically to 2050. And so we work with third-party, marketing firms. We've done our own research, and we believe that Europe needs to install 200,000 industrial heat pumps between now and 2050 to truly meet their decarbonization goals. If you know anything about these type of projects, products, they're very complex. A lot of hands involved, contractors, engineering firms, suppliers. The sales cycle is very long. You need project managers. And so when you look at this on a yearly basis, on a daily basis, we're talking about a lot of these complex heat pumps needing to be installed every day. So there's a huge market potential. And so this is certainly an opportunity that we see as favorable, but also a challenge. And so as we were developing our product, we kind of came up with this equation, right? We want a product that's as standard as possible. Standard components, compressors, compact footprint, the way you build it, the same every time. But we also didn't want to do that at the expense of the customer, right? They want a product that's specific for their application needs. They want to make sure the value is maximized for their specific application needs. So we genuinely believe if we can do both of these things, have a standard product, but it gets flexible as well, is that we actually have a scalable approach with the opportunity and problem statement I just showed. So we believe that we've actually been able to do that with our VQ95. So this is our water-to-water industrial heat pump using ammonia as the working fluid. We can do 1 to 5 megawatts of heating capacity on a single skid, very compact skid. And we can do water temperatures up to 95 C. It's a modular plug-and-play solution, and so it's perfect for district heating applications that require, say, 10, 20, 30 megawatts of heating capacity for a single application. The VQ95 leverages our single screw technology. This is technology that's been in our portfolio for 20, 30 years. It's a technology that's been used in heat pump duty applications in Europe for 15 years at very high temperatures. The uniqueness of this design is that all the forces that act on the screw are balanced, both radially and axially, allowing us to operate very reliably at these higher temperatures, higher pressures. We can also modulate the capacity, the volume ratio mechanically, and so we say VFD is optional. This design is tolerant of liquid droplets, meaning we don't have to design our system with superheat in mind, which allows us to boost our COP. So here's some additional details on the unit itself. We have 2 compact footprints. The 240 frame is in our booth right now in Hall 6, so you can see that footprint. And not for much larger, you can get up to 5 megawatts. So it's very compact, perfect for district heating applications. So we're really focused on maximizing efficiency, simplicity, reliability, and ultimately flexibility. Because it's plug and play, we can stack these next to each other in series or parallel and very easily get to these higher capacities for district heating applications. So Jonathan is going to come up here and talk about a recent order that we secured that we're working on fulfilling. Thanks, Jonathan. You got to run the mic? Or the... yeah.
Good morning, everyone. It's my pleasure to present for you today a short case study from Canada. This is a district energy application where the customer has purchased 4 VQ95 heat pump packages. In this case, the heat source is a wastewater sewage pipeline. A little bit about the customer in this case. It is a community of approximately 350,000 people. It is a community-owned system, and the system serves a diverse range of customers. So we have small residential, large residential buildings, we have some commercial units, we have some educational institutions, and we have some healthcare facilities. The district energy system currently serves 1.3 million cubic meters, square meters of heating and cooling space. And using the sustainable infrastructure that they currently have today, they are saving 7 million cubic meters of natural gas per year. And by continuing to adopt natural, sustainable solutions, they plan to drive that number up every single year. The system has a planned growth of 100% over the next decade, and they plan to meet a lot of this new demand using heat pump technology. Over on your left, we have a diagram, a simple diagram of how this system is going to be constructed. So the first stage is done with chillers. Those chillers reject their heat into a interstage hydronic loop, and that is where our heat pumps absorb that thermal energy and elevate that temperature to 95 degrees C, which is injected directly into the heating system of the distribution network. At the top, we have our wastewater source at approximately 5 degrees C. This is coming from the heat exchangers used in the wastewater system. So they're very specialized equipment to handle the solids and the liquids from those wastewater streams. Short technical summary. So as I mentioned, the heat source primarily comes from this wastewater energy transfer system, which is specialized technology for sewage water streams. It separates the liquids and solids and then puts them back together, and those solids and liquids are turned back down the sewage stream. And they provide, as I mentioned, a consistent source of energy to the chillers of approximately 5 degrees Celsius. On the heat sink side, we receive water back from the heating network at approximately 60 degrees Celsius and inject that back into the heating loop at 95 C. So there's no need for top up with their boilers in the system. We are part of a large network there. It's approximately 50 megawatts of base load. They see that doubling in the next decade. So they do have some boilers on the system today, and our system is heavily base loaded. So our system through the heating season is planned to run flat out 24/7. And thanks to the configuration of our systems, we have 4 packages. Each package can go down to, they have slide valve capacity control. So we can go down to less than 25% of the design heat output on the system for the shoulder seasons. And the design thermal output of the system is 18.5 megawatts. In closing, the Vilter advantage here at 95 C, we have the very high thermal density for the footprint required of this equipment. So they were able to fit a lot of equipment output in a very small area. And the equipment was found to have a very low cost of ownership over time. That includes the CapEx and the operating costs of the equipment. And then thanks to the low maintenance required on the single screw technology, we have very high equipment availability for this equipment over its life cycle. Thank you.
Thank you, Jonathan. Really exciting application that we're a part of, one of many that we expect to be part of with our product. This is our formal launch at Chillventa. We've been working on this product for over a year now, a lot of hard work. We think it's very suitable for applications such as this at very hot temperatures. I'd encourage you to stop by our booth after this, ask us as many questions as you want about the product. Here's our sales contacts by region. So Andrew, raise your hand. We've got Jonathan, obviously, and Gary's based in the U.S. And then please, scan this QR code. We post quite a bit on our LinkedIn, new products, updates, case studies. We'd love to connect with you on there. So thanks for your attention. Thank you for your time. I hope you enjoy the rest of your day at the show.